For New Horizons, I'm a science team co-investigator, so I had a lot of input early on in terms of designing the mission, exactly what kind of cameras, what kind of instruments do we carry in order to try to define the science questions that we should address, and then how do we go about making the measurements that will give us the most science in return. After getting the mission designed, and then it's writing the scientific case for the mission, it's all about trying to now make sure that what we do and what we measure, everything that we're doing in our time in approaching Pluto, at Pluto, and going beyond Pluto, that we're making the smartest use of all the technology, of all the data that we have to try to get the best data to give us the most solid scientific answers we can. So it's a balance and it's a juggle, because you want to know everything all the time, but you have to make choices. One of the great things about New Horizons is it's really an extension of the human psyche, the human curiosity out to the farthest reaches of the solar system. And the reason we do it, and I think the reason why we're all interested in it, is because we're all naturally curious beings. And here's a way of carrying that curiosity to about the most distant location that we can possibly reach. MIT has historically been a center for the study of Pluto, and it began with Professor Jim Elliott, who was among the first to detect that Pluto has an atmosphere using techniques of stellar occultations. And over the years, through the graduate program here at MIT, we've trained a number of students. Even this most recent issue of Nature has this pair of students who are brother and sister, Leslie Young and Elliott Young, who each came as PhD students in EAPS. Elliott was my student, and Leslie was Jim Elliott's student, and they're now both heavily involved. Another PhD member of the department is Kathy Olkin, who also works for the PI for the mission. We have Angela Zaluka, who's modeling the atmosphere of Pluto. We have Amanda Zangari, brand new postdoc who took a postdoctoral position with the Pluto mission. Zangari was my student. But by and large, these are a lot of legacy students from Professor Jim Elliott, and then more recently through me. I think what's exciting about New Horizons is there's only once that you can do something for the first time, and you know it's going to be historic, because it is historic to see something and reveal something in nature that has never been seen before. And we are the team, we're the generation, we're the era that is actually doing this far reconnaissance of the solar system for the first time. In a historical context, I always think about this like Lewis and Clark. 200 years ago, the frontier of exploration was going across the continent of North America. Now it's completing that reconnaissance across the solar system. And it's really amazing to think that that's how far we've come in 200 years, from exploring the continent to exploring the entire solar system. I've been exploring Pluto since the 1980s, trying to decode and understand what Pluto is, and that's involved using ground-based telescopes and also the Hubble Space Telescope. And what's exciting now is with New Horizons, as we get closer and closer, we will soon exceed everything that we've been able to do from the ground. And it's very exciting to see what parts of the initial work we've done on Pluto we've gotten right. We'll find out what parts of our initial understanding about Pluto were just plain wrong, and in many ways, finding the things that were wrong are going to be the most exciting things, because it's nice to pat oneself on the back and say, yeah, we knew that, we got it right. But nature is always much more complicated than we ever can make it out to be. And so that's what we're looking forward to the most, is seeing where is it that the natural state of Pluto just blows our mind and is just beyond anything we can possibly anticipate.